Hi. Working on the BYD batteries. I have to disconnect. Well, I already had disconnected them, but have to get them out of here. And I am a little scared because when I measure the voltage, they're fully charged. So, but the terminals are really in bad shape. So I'm going to show you what I'm talking about. Hold on, watch it. See, these top batteries took most of the fire damage. And on this side I had other batteries which protected these batteries, but you can see the fire damage down there. So I believe these this one are totally not very safe to move around, because the problem is, see this right here, I had there's a wrench right here. This is a wrench. I had tools sitting on top of these batteries, in a box of course, but the toolbox melted and all the tools and all the stuff, the plastic stuff melted, and these basically sunk into the battery plastic. So I've been taking it out, but look how close it is. These batteries were very close to begin with, but of course there's all kind of nuts bolts in the middle, and if I disturb it, then what will happen is that something can get short. And especially with battery being fully charged, I'm surprised that they are still holding the charge. I thought it would be dead, but they're not dead. Hold on, let me show you what I'm talking about. So this battery looks like pretty bad shape, right? Like, it doesn't look like there's no any chance this would have any juice in it, but let's see, which is scary part right here. All right, excuse my cheap Harbor Freight meter, but it will work. I had an expensive one, and that one burned too in the fire. So if you notice this, so it's hard to hold these. Okay, so maybe I should hold it. Oh, there you go. Okay, hold on. Maybe I can. All right, there you go. Okay, so that bit poked in right there, and that poked in right here, and okay, maybe this is, see, 27.2 volts on this battery in this condition, and look how close the negative bus bar is to these terminals. Right now it is resting. It didn't used to be. I think it kind of melted and connected itself. So this is the negative bus bar. See where I'm connecting, and it's still live. So pretty dangerous. So my thought process here is, when looking at this, is why is it not measuring here? There you go. Okay, see, 26.9 just by connecting these two terminals together. So it's got full charge. These are 24-volt batteries. Completed discharge is 2.5 volt per cell. You're looking at about 20 volts, so that is not good. See, it's got full charge. And why is it going up now? Okay, that's scary. It's bouncing back and forth. Oh, 30. So it's kind of highly unstable. I don't know why. And I can't move these batteries without causing some kind of short. I'm pretty sure this is the same situation. I'm going to show you that voltage on that one. So be very careful when you have stuff like this. So okay, yeah, the terminals do look bad, but this thing is not dead. See, 27.3. So wow, these are some tough batteries. So I think the kind of reason that these still have power in them is the heat sink. Okay, it's going up. So I don't know if it's actually just faking it or what. 35.9, huh? Okay. Why does the voltage spike? Maybe it's, I don't know. Is it safe to even just charge it? No idea. But yeah, I can't move them like this. They're like kind of like a, I removed the top plastic part. So if you notice this right here, see that? How bad? So whatever was on top, aluminum stuff melted and fell on it. Same thing is true here. A lot of mixed metals in there. So these batteries are scaring me. So I think I have like 6 batteries that are in, like that one down there too is I mean, yeah, it's in pretty bad shape. So I think this one probably is okay, but yeah, they're really tough batteries. Aluminum heatsink right here probably help protect them, because otherwise it would be a big problem. See, 27.6 volts. So I have to somehow discharge them. I think I'm gonna put some kind of load on it, like a UPS or something, and plug it in and discharge them. All right, so hi YouTubers, this is Vasif again. I figured out a way to how to discharge my batteries. These batteries need to be discharged so they're safe to move around, because right now the way it stands, I don't know if they'll be a short if I move it around. They're fully charged right now, and I just don't feel safe touching them. And if there's any stored energy in them, that could be bad, because there will be heat, there will be short, there could be fire. So I don't want another issue with it. So what I'm doing here is discharging these batteries. I'm going to show you how I'm doing it. Okay, so you see these loads. This work light, it's 500 watts of load. On these batteries, they're big. So what I've done is connected the UPS APC 1500. This thing can do 865 watts, but I don't have anything that will match it exactly, so I can't put 865 watts load on it. It would be better if I did. I'll find something I can put it on. Other than that, this is the reading, voltage reading. As you see, 26.9 volts. So I'm waiting till it gets to 20 volts. Then it will be safe too. And of course, as you see, the UPS right there. The UPS has an issue with battery status. That's why I am using it for this. I don't care if it burns out or it gets damaged, because they say UPSs are not designed for continuous run like that, but this is a pretty high-end UPS. Okay, so I cut the cable off of it, and instead of trying to fix it, I'm just using it on battery. It works. I mean, it just doesn't give you the battery status. No big deal there. I'm just using it as an inverter right now. So hopefully it discharges it at 500 watt load. I will say 8 hours. 8 hours if it's 4 kilowatt hour battery. So I will find out exactly how much power is in these batteries also. That's going to give me an indication of capacity versus the that is completely discharged. Okay, all right, well, I'll keep you updated. Oh, and another thing I found out, that because this APC has PWM inverter built into it, it doesn't run this heater, fan. So I believe the heater was turning on, the elements were working, but the fan wasn't turning. So I guess this thing is not good for motors. Works for computers, lights, but not really for the fans or motors. So you just I couldn't use that at load. This would be more close. This would be like a 700 watt load at low settings. This is 500. Tried another light, but light didn't have juice, so I might find something else I could plug it in for 200 watt, another light or something. Yeah, I have another light. Why don't I plug that in? Okay, I will do that and let it drain at probably 600 watts. Okay. All right, so I have figured out how to put more load on this UPS. It's gonna drain another 800 some 50 watts. This is as close as I can get to it. I'm using two halogen lights. One of them is 500 watts, the other one is 250, and then I have a LED light which is putting in around another 100 watts, so that's 750 plus 850, so 850 watts. So this is pretty neat. I'll show you what I did. Okay, so this is the 500 watt light, pretty bright. This is a halogen, so it's not really LED, so this generates quite a bit of heat, but no worries. Yeah, it's 500 watts. And then we have this light right here. Had two lights, each one of them is 250, so I turned one off because thing is rated, my UPS is rated for 865 watts, so this is 750 total added together. And then this is a LED light which is another 100 watts. So total load, I mean, I don't know why the gauge doesn't maximize it. It still seems that there's room, but if you read this, yeah, if you read the output of a 1500 volt amp UPS, which is what I have, 1500 volt amp, so that's 865, which is the maximum you want to go. And yep, I'm maxing it out right now. I don't see any, it's not warming up or anything like that, but it should drain these cells very nicely. Apparently the voltage has gone up. I don't know why the battery voltage is going up. Okay, so there's some issues with the connection, the way I've connected it. 26.7 going down. Yeah, but quite a bit of power. At maximum load, I would say it will still be 5-6 hours. So we'll see how this goes. And once that battery's gone, charge wise, I'm gonna drain this one, that one, and then these two probably. Yeah, anything with really yeah, I mean, you can see the light right here. Look at this. This is supposed to be battery terminals. These 220 amp hour cells have 8 cells in there, and these are aluminum bus bars. The biggest thing that freaks me out is this negative one right here. This is the negative post, and look how close this is to the positive terminal. So yeah, that, and I'm surprised the cell didn't die. So whatever the insulation was is still there, kind of protecting it. So I want to drain this battery down. I don't know if at this point it's a good idea to drain it, because yeah, I need to figure it out. I will look at the specs. Yeah, this is pretty sketchy. Yeah, I might have to move that negative bus bar. Yeah, I don't feel safe. So yeah, the way I think it works is from the opposite side of that cell, the negative bus bar comes in, and then this is the first positive, that's the second positive on the side, third positive right here, fourth positive on the other side, fifth positive, sixth positive, seventh positive, and eighth positive. So that's where the positive comes in. So at the bare minimum, I'm just going to short that one cell, which I don't want. I might be able to maybe move it a little bit. We'll see. But yeah, that's pretty bad. It looks like it's, yeah, it's just, okay, can you see this? This is supposed to be 12 gauge steel. Look how it bent. This is all because of the heat. And my poor inverters. Yeah, looks like the fire started right here and it spread out all the way till here. And of course the batteries over here were okay. This is, of course, I removed the cover, but there were batteries on top of it too, so those protected these batteries right here, so it didn't work. But I had some wood in between to kind of like protect it from touching here, this metal piece. so I wanted to put some gap in there, and I didn't want batteries touching each other, so I put some wood in there, and that burned. That's still 2x4, 2x6 probably in there. So yeah, there's some wood in there, so that's probably why the fire went all the way down there. If I didn't have the wood, it probably wouldn't have. But plastic definitely doesn't burn as long as the wood ones. So, and the steel definitely, when it melts, this means the flames were really high. The concrete wall is okay, nothing damaged. I just have to use the wire brush to clean it up, and it will be nice. I will be replacing all these 12 gauge steel. I'm not gonna, as you can see, I have already replaced the panels. They're temporarily on. They're not sealed, so water still drips in between. I've replaced 4 panels so far, but I will be replacing 2 more on this side, and yeah, 2 more on this side, and then I have to replace probably 4 to 6 on this side. As you can see this right here? Yeah, that's not good. They might still work, but I will replace them. All these panels will be gone, and I have to replace the steel struts, so I don't want to, you know, this is how it looked like, and this is definitely not looking good. Yeah, see, it's rusting or whatever. It shouldn't be rusting, it's steel, but it was coated galvanized, but I believe because of the fire that galvanized coating came off. You see the rust is developing on this right here, because the coating is no longer effective, and I don't want that here. So I'm gonna replace all these pieces, including the one in the back. So all those, I already have the pieces over there, so that's not a problem. And then I have to take the inverters out. Yeah, once I get the defective batteries out of here, then the rest would be I would put a BMS on them and then cycle them, see how they are. They should still be good. I don't know, but I will find out. Yep. All right, that's all I wanted to say today.